Here we are taking a look at a power function word problem. So as I read the word problem, it says, given that blood flow is proportional to the fourth power of vessel radius, find the power function to model the data. So as I read this, blood flow is the first variable that I encounter. I'm going to use S for blood flow. Proportional, I know that is the idea of multiply. And it's to the fourth power. I know that I'm going to need that. It's a power function of vessel radius, so that is my second variable, and I'm going to use R for that. So writing this out, I have blood flow is equal to some constant that I don't know. You can use C or K for constant. Either one works just perfect. Times the vessel radius, which we said we're going to use R, to the fourth power. We notice here that when we have both the words, our English language, and we have a chart of data, that the blood flow came first in the words, and that's why we started our formula with S. And when I look in the data, the blood flow is the second column, which is really the Y column versus the X column. And so that also makes me put the S, the flow, first. Now, in this chart of data, I have a pair of numbers, and so I want to plug them into my formula. So when the blood flow is 4 milliliters per minute, what I know is that the vessel radius is 1.5. So I put that into my formula. First thing I'm going to do the algebra is I'm going to do the 1.5 to the fourth. So I just write that 4 is equal to K times, and 1.5 to the fourth is 5.0625. And then to finish my algebra, I need to divide on both sides. So divide by 5.0625. And this gives me a value for K, and you are going to have to round that off somewhere, but I got 0.790. So my actual power function is that the blood flow is equal to 0.79 times the radius to the fourth power. Now I can use my formula to figure out these other values. So the next value is when the radius is 2. So I just put in 0.79 times 2 to the fourth power. And type that on my calculator, hit equals, and I got 12.64. And so this, to me, is always amazing. But if we change the vessel radius by literally half a millimeter, the blood flow is like 3 times, almost 3 times as much. So it's really, really huge impact, and that's why you have that vasodilation and vasoconstriction, which helps your body move your blood around to the right area of your body. So that fourth power exponent really makes a difference in your blood flow. And so we're going to repeat. We're going to finish out this by doing the last one. And again, we'll just type that on our calculator, and I get an answer here of 30.86. And so that gives you an example of taking the words where the word is proportional and writing a power function for that.